Good morning one and all. Today we are going to study the practical on analysis of beam. So while doing the analysis of the beam, first we can design. If you are asked to draw any mechanical component or any 3D component, you need to draw a mechanical component or 3D component from this parametric or any other softwares. So first I will take a rectangular beam for the length of 500 200 by 200, and then it can be extruded by 100 mm or 150 mm symmetrically both sides. This file can be saved as by IGS file, and please I want to give the name it to the beam or cantilever beam. So hence we can save the file cantilever as a solid through the PO parametric. Then we can import this file. So first we can edit the 3D, static 3D, and in this static 3D we need to import the file, that is your cantilever beam IGS. So after importing this, we need to generate the mesh. So after generating the mesh, we need to apply a material to this component. So go to the mesh component and assign a new material to this plate membrane. Whatever the 150 mm die mesh thickness is given to this beam, an isotropic property from this isotropic 200 E3 is the Young's modulus and Poisson's ratio is 0.3. So close the window. Then we need to apply fixed support at one end, and so select this and go to the fixed support and click OK. So you can fix the particular area. Next we need to select the other end, which is a free end, which is having some forces over it, and it is directed towards whatever the direction it is directed. You can apply this. Suppose I want to apply x direction forces, negative x direction forces 1000, that is a comprehensive type of forces. Then you can apply the forces. So for on the forces it is distributed, that forces whatever the 1000 or 100 Newton force you are applying, that can be distributed over this element. Okay, so we have created 46 element and 138 nodes. So solve this problem, and whatever the results you are getting, you just check it at displacement analysis plot, you can find out. So whatever the displacement takes place, you can see the animation over it. So this is the displacement. The minus 3 point is the maximum displacement, minus 3.127 is the minimum, 10 raised to minus 5 is the minimum, and this is the color ranges. Okay, so in the table you can find out the displacement. Whatever the surface you want, you can select these surfaces and their results you want. You can find out displacement in x direction, displacement in y direction, and first you have to default and then click OK. So you can find out the, or select all, so you get all the surfaces results, and this, from this you can find out the displacement in x, y and z for the different nodes. Okay, for the elements if you want, you can find out the result for the elements. Okay, so for this element just click over the 1 minus places, so you will get the 1 minus places for these elements. Okay, so these stresses you can find out. So the red region shows the maximum stresses and blue region shows the minimum stresses. So these stresses you can find out. One mass is bottom surface, upper surface, and overall stresses if you want you can find out principal stresses. So whatever the input is given, according to that it will show the output. Means if you are given in Newton per mm square, the result will show the Newton per mm square. And these are the reaction forces. So that's all. Thank you.